is it that we are going to be doing today? So let's just take a moment and look at a definition for a second, and then we'll go from there. So the topic we're dealing with is probability. And in the past lessons, we have dealt with different structures that help us understand basically different groups of events when we deal with probability. And the first structure we dealt with was the Venn diagram. And then we dealt with the tree diagram. And then today, the final structure we're going to work with is something called a two-way contingency table. And a table is just a table. It's just got rows and columns. In this case, it's a tool for organizing data, especially when we want to determine whether two events, each with only two outcomes, are independent or dependent or independent. The counts for each possible combination of outcomes are entered into the table, along with the totals of each row and column. Now that sounds like a mouthful, but when you see it in the lesson, you'll see it's not too bad. Then the other bit of theory that is going to be used during the lesson is going to be this idea about independence and like how we can use that. So remember, when events are independent, when we know they're independent, you can work out the probability by using this identity. So that's if we know they are independent, we can use that identity. P of A and B equals P of A times P of B. However, we can also use this rule if we have two events, specifically in a table, and we want to show that the events are independent. We need to then show P of A times P of B equals P of A and B. And again, the only reason I'm bringing this up at the beginning is I want it to be sitting roughly in your head when we actually look at tables. For the moment, I would expect most of you are still feeling a bit like you saw this in class, but you were like, what does it even mean? So what I'm going to do is really try and connect this bits of theory with an actual example like we have below. But I just want a quick vote from the class. Have you seen a table of data used in probability, and have you seen these types of identities before? Give me a thumbs up if you've kind of seen something like this before. Give me a thumbs down if you've never seen anything like a two-way table or a P of A times P of B. Just want to get a sense of how much knowledge you're bringing to the class today. Most students do find this connection a little bit a little bit abstract. So I'm going to do my best to connect the two. Okay, so all I want you to think about is we're going to be looking at tables of data, and the tables of data relate to these two events with two outcomes. And then we're going to try and use those tables to often show that those two events are independent. That's kind of the summary. But let's just start with a very simple interpretation of data. So we have a table of data here, and on the rows we have boys and girls. And so I would call this event gender, essentially. And then on the columns, we have different sports, and we have a comment for favorite sports. And these are broken up into various outcomes. So gender can be boys or girls, and favorite sport can be football, athletics, or other. Now, there are no total columns at this stage. What I want you to try and do for me is I want you to try and answer A, B, C, D using the information on the screen. So let's just start with that. I'm just giving you a table of data, and I want you to try and interpret that table by answering the questions A, B, C, and D, which are here. And I call this kind of like table literacy, right? You just understanding how to interpret information from a table. So I want to see in the chat, or if somebody is willing to raise their hand, that's also good. I want to know how many boys choose athletics. What was the most popular sport with boys? how many girls are in the class. And I'd love to hear your voice if you're feeling chatty like me today. Yeah. How many boys chose athletics? So it feels to me boys athletics is going to be 4, because that's going to be that amount there. Keep those answers coming, guys and girls. I see lots of answers coming in the chat, which is fantastic. So who would like to tell me the answer for B out loud? If you just raise your hand, you can tell me your answer. What is the most popular sport with boys? Can you unmute Khamot-san? Can you hear me, Khamot-san? What is the most popular sport with boys?
It's the football.
Perfect. How did you know which one it was?
The biggest number between the sports is the football.
Okay, exactly. So the football, and then you also looked at the row of boys because that was the one over there. Fantastic. Yeah. Could you answer C for me while I've got you on the line? How many girls are in the class?
Okay. 16.
16. How did you do that?
I added all the numbers, including the numbers that are in the girls row.
Perfect. Thank you so much. You're a superstar.
Thank you.
Okay, now, the last question is how many pupils are there in the class? And there's something that I have to do. When I've got a table, it gets quite hard to work with unless I've got certain additional information. And I was wondering if someone can help me get to D. How am I going to do that? Okay, Katlego, let's go to you. Can we unmute Katlego, Lebo?
Yes, space.
Katlego, how would you go about getting this? How many pupils are in the class?
I think I would add all the number of pupils that are in both boys and girls, Mr. S.
Which one would you add? So I've got the 16, would you agree? So that's a total. Which one would you add next?
The other 15 that's in the boys.
Yeah. So you would basically add the columns there of that. And then what did you get as your answer?
I got 31, Mr. S.
Perfect. Absolutely perfect. Now, what I want to suggest is whenever you have a two-way table, you actually want totals in all the rows and the columns, because let me draw a little line. The sample space for this question is here, right? So those are all the different types of people that exist in the sample space. There's 31 people in this grade 7 class. However, if I start asking you questions about different events, it's really helpful to have the columns and row totals. And so I would always, if they don't give it to you already, it's a helpful thing to be able to work out. And what you notice is 15 plus 8 plus 8 will also give you 31. So the column and the row totals will always add to the same amount. And that makes logical sense when you think about it. So just give me a thumbs up if you understand the importance of totals and you know how to calculate the totals. Okay. Now I want to ask you a probability question. So in this sample space, there's a group of grade 7 students, and I want to ask you, if you randomly choose one person from the group, what is the probability that they are a girl? Okay, let's go to Kwezi. Kwezi, what's the probability that a randomly chosen person here is a girl?
It's 1/7, sir.
1/7?
Yes, sir.
Would I think I would. 1/7. I
Okay,
think
can
it's
you
something
please repeat the
slightly
question?
different.
Can
So
you please
what is?
repeat the question, sir?
Yeah,
Can you please
So
repeat the
if-
question?
I will do. If you or choose one random person from this group, what is the probability that that person is a girl? That's what I want to ask from this group. It's a little bit more sneaky than it sounds. I'll give you a
It's
little
1
hint.
over- Okay, the probability may be 1/62.
You're getting warmer, so I'll give you a hint. Whenever we calculate the probability, we always ask how many possible outcomes are there and how many favorable outcomes are there. And if the question is asking about all the possibilities, there's 31 different people in this class. The question then becomes, what is this bit going to be? Would you like to phone a friend?
I would attempt it.
Would
I would
anybody like
attempt it.
to
Can you please repeat the question, sir? I'm sorry.
No, it's fine. So what if a randomly
The
chosen
question is a bit tricky though.
Yeah, it is. Okay, let me go to who is it all where to? There we go. Who's let's go to Kukle. Kukle, can you help me out?
Yes, sir. So I would say the answer is 16/31 because there's 16 girls and the total is 31.
Okay, so this is the key, right? So number of possible outcomes is 31. In this question, it would be 16/31 because I asked you what's the probability of it being a girl or the person being a girl. What's the probability that a randomly chosen person is a boy in this group?
15/31.
It's going to be 15/31. Exactly.
Yes, sir.
What do we notice? What's the fancy word for these events?
They are independent of each other.
Okay, so we'll get to that later. Not at the moment. These are actually called complementary events.
Okay.
Because they basically fill up the whole sample space together, and they are mutually exclusive. So boys and girls are complementary events and they're also mutually exclusive because if in this case, if you're a boy, then you can't be a girl, right? So in this situation, it's a complementary event. Okay, so that's just some extra vocabulary that I'm showing out there. The same way, okay, let me ask another question before I get too wordy here. What is the probability that somebody likes somebody's favorite sport is athletics? What's the probability that a randomly chosen student's favorite sport is athletics? Yeah, so it's still going to be out of 31, but it's going to be, if we look at the summary of our sample space, how many students whose favorite sport is athletics? It's going to be 8, so 8 out of 31. And if we wrote that as a decimal, it would be easy to convert, right? So what you see is tables are a lot like Venn diagrams in some ways. Once you know how to read them, it's almost like they're these little spaces, little holes in which each group lives. Okay, how about this? What is the probability that somebody is a boy and their favorite sport is athletics? So if I randomly choose someone from this group, what is the probability that they are a boy and their favorite sport is athletics? Now think about the and means something specific. in order to get into the club, so you still have 31 possible people. That hasn't changed. But your favorable outcome is only a very specific type of person. It's a boy whose favorite sport is athletics, which is going to be here. Take a moment to see if you can see what I'm talking about. So the probability of somebody being a boy and favorite sport being athletics is just going to be 4 out of 31. Lusanda, let me come to you with your question.
Hello, sir.
Hi, Lusanda.
So my question is regarding the question you just asked. What is the probability for boy chosen at random does athletics? Isn't it that you take your 4 and then you divide it by 15 because you're only calculating boys, not everything. It's only about boys.
No, so we are looking for the way the question is asked, and I suppose because I'm saying it verbally, it's not as easy to see, is I'm saying you're choosing a random person from this group of students, and there's 31 in total. And so the only people who are favorable for my question are ones that are boys and whose favorite sport is athletics. So that's why it's 4 out of 31. But there is a type of question like that, but that's not the question I'm asking right now. But I sort of get why you're a bit confused there. Does that help a little bit, Lusanda? Yeah. Okay, let's move on to another. I haven't got to the independent stuff yet, but I'm rather going to move on to another question, and then I'll talk about the independent events after we've mastered tables. So let's all try and answer this question. So you're given the hair color of 50 students were recorded, and you'll notice that the table I've given you here has total columns. So thank goodness for that. I want you to try and answer, and I'm going to give you a good 2 or 3 minutes here, questions 1, 2, 3, and 4. So you're choosing a student, a random student from this group. What's the probability they'll have brown hair or have blonde hair, or, I'll let you have a crack at that. I don't want to steal your thunder. But if you have questions, please do raise your hand.
Mr. S.
Mm.
There's a question from Katleho.
Yeah. What is the question? Or is it a raised hand?
A raised hand. I will unmute her.
Awesome. Awesome. Awesome.
No, Mr. S, I just wanted to refer back to the probability question that you asked before we moved on to this one, because my answer was definitely different. I said it was 15 over 31, close brackets, and then 8 over 31, because I thought that we were adding the number of...
It was an and because the question had an and in it, it had to be the intersection. It had to be the people who were in both groups.
Oh, okay.
Did that make sense? Because it was boys and favorite sport athletics. So it's almost like it's not either or. It was you had to be both a boy and have a favorite sport of athletics, which is a small group. It's the intersection.
Okay. Thank you, Mr. S.
Pleasure. Amukulani, what's your question?
Good afternoon, sir. I also kind of did the same thing as her, but because it said and, I said 15 over 31 times 4 over 31, but then it makes sense why it's 4 over 31.
Yeah,
So
I was just, you know what it was? I think we're mixing up the independent events thing. And I think the way I worded that was a little bit confusing. So as long as you get the basic idea, I was trying to say there's a small group inside of this thing, and I wanted to get that group. But the fact that I used A and B for athletics and boys, not A and B like we normally do, is probably what's causing the confusion. So let's just make sure we've got this next question right, and then we'll go from there. Okay, so who wants to tell me brown hair? What is the probability of a randomly chosen student having brown hair? It looks to me like I should just go here. So, because that's the row with brown. So 17 people have brown hair. And so if I choose one random person, there's a 17 out of 50 chance that the person will have brown hair, or in percentage, it'll be 34%. Now, I'm not going to answer any more for now. That was just the warm-up tip. Who would like to give me the answer for blonde hair? What's the probability that a randomly chosen person has blonde hair? Now, remember, there are 50 people in this group. Now, where do the blonde-haired people hang out in this table? They seem to hang out over here. And so we'll have blonde hair. What's the probability of choosing someone with blonde hair? Yeah, it's just going to be 11 out of 50. Nontokozo, you are on the money there. Now, 22%, Rodley, you're absolutely correct. For question 3, we'll have black hair or brown hair. So this is where we have to be a little bit more interested. Black hair or brown hair. Look, it's still going to be out of 50, right? Because all of these questions, the class is out of 50. But a favorable result for us is going to be having black hair or brown hair. So black or brown, those are both going to be happy outcomes. So if I ask what's the probability of getting someone with black or brown, I add them together and I get 39 out of 50, which is the same as 78%. Who wants to give me the last one? What is the probability that a randomly chosen person will have in this thing blonde or brown or black? Yeah, Kuchle.
So I said the answer for number 4 is 50 over 50, so basically 1.
Yep, 50 over 50, or is 100% chance, because the only hair types are black, brown, or blonde. So if any of those comes up, there's 100% chance that you will get that hair color. So that makes a lot of sense, right? So it's not very likely you'll get a blonde-haired person by himself, but it's very likely you'll get either a black-haired, brown-haired, or blonde-haired person. Okay, give me a thumbs up if you're feeling a bit better about tables. Give me a thumbs down if you still feel a little bit unsure about reading data in a table. Just want a quick little check-in with the people of the room. Okay, so now what we're going to do is in later questions, we might start to leave some of these tables blank. But for now, let's talk about if we wanted to work out whether or not hair color is independent of gender. So if we look at this table, on this side, we have hair color. So that event, that's hair color. And over here, we have gender. Okay. Now I'm going to show you how do you work out whether or not hair color is independent of gender. And all you need to do is the following. You work out what is the probability of, in this group, the probability of a randomly chosen person being a girl. Then you work out, and you could have chosen boy. It doesn't matter which one you choose as long as you're consistent. Then you're going to work out the probability of someone having black hair. Let's just say, I'll use I'll use the full notation. So probability of that. And then you also need to work out what is the probability that someone is a girl and they have black hair. So these are the 3 bits of information that you need to work out from the table. And then once you've worked that out, I'll tell you how we can decide if these events are independent. So let's call this A. Let's call this B and this C. and you can tell me what is the probabilities for each of those. Selwyn, this actually falls under probability, but it's just using tables. And before I even talk about independence, let's just work out, using what you learned earlier in the lesson, what's the probability that a randomly chosen person is a girl in this particular question? Let's just try and do that first. And then let's work out the probability that somebody has black hair. And then let's just see what we can get. And I'll trust me on this. I'll get you there. So the probability that a randomly chosen person is a girl is going to be 24 out of 50. Okay, or 48%, yeah. What is the probability that a randomly chosen person has black hair? You guys are winning, so that's A. I want a few more people to tell me what's the having black hair in this group. So let me see if I can find it. I think black hair is over here. So okay, now last one. What is the probability that a randomly chosen person is a girl and has black hair? So it's just going to be 10 out of 50. Okay, so now how do we use this to tell us whether or not the two events are independent? So gender and hair color. All we need to do is we take these two over here and we multiply them together. So if we multiply them up together, we get 24 over 50 times by 22 over 50. And what do you get? Let's look. So this is the A probability of A times the probability of B part. Let me get my times by 22. Okay, so I get 0.2112. And if you look over here, what is the probability of this one? What's 10 over 50 as a decimal? So 10 over 50 as a decimal is just going to be 0.20. Okay, so what does that mean? So in this case, the events, they're not independent, because in order for events to be independent, the probability of A, now in this case, this is just notation, it's not equal to the probability of A and B. So they aren't independent. So it's a little bit confusing because the A and B is just a generic notation. But if you look at what I did, I said girls by themselves. So girls was like the A, black was like the B, and then A and B was just girls and black. And because they're not equal, the multiplication of the individual ones is not equal to the and, we say they're not independent. It's better to say not independent. Yeah. Now that is a tricky question, so I don't want us to, we're going to do another one later in the lesson, but I just wanted to give you one kind of look at how we construct it. And the other thing to notice is I use girls and black hair, but there are other ways to do this question. So you could have done it with boys and black hair, or you could have done it with boys and blonde hair, but I just chose the simplest one. And the simplest one for me was just the first row in the first column. So can you see it's girls and then black hair? And so for me, that just seemed the easiest way to do it. So give me a thumbs up. I don't expect you to know it super well, but give me a thumbs up if the basic idea makes sense. We're going to practice this quite a few more times. Okay. Now, because I've put all this maths into your brain needs a break. And so what I want is I want everyone to stand on their feet, and I want you to just stretch it out. And Lebo, if you could please assist me in just encouraging our young students to just get up and stretch it out. And just don't be afraid to
Come on,
shake it.
guys. Please
Do
turn
it.
on your cameras. Join us in the stretch. We'd
Yes.
love to see your faces.
I want to feel the solidarity. Let's feel the
Shout out to Beyonce, Chalanati, Kwezi, Katleho, Rodley, Tohi,
yes.
Mbuso, William.
Oh, can you feel the
Oh,
goodness? Your body's
yes.
like, thank you.
Loving
Thank you for
this
taking care of me.
energy.
Ugh. There we go. We'll show those tables and spots. Okay. Now, a break wouldn't be complete without a brain break question. So here is my brain break question for today. So you have a bat and a ball, and they cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? You may be thinking, Mr. S, surely you can bring something a little more exciting than this, but I say, watch yourself, because this is an interesting one.
Don't speak too soon.
The maths teachers are sneaky, guys. You got to watch yourself. We like to think deeply about these things. Okay, so whenever you get, I always like a good diagram. So let's say here's a bat, here's the ball, and if the ball costs 10 cents and the bat costs $1 more than that, that would make that $1.10. But then when I add them together, I get $1.20. Oh my goodness, the world seems broken. Are you guys following me so far? So if a bat and ball costs $1.10, and the way I'm laying it out, I'm getting to $1.20. So now strange things are happening. Vuyile, you're on the right track. So Vuyile is saying, if this was 90 cents and this was 10 cents, but then I only get to 1 rand exactly. This one will mess with your brain. Kukle, you're on the right track. So how much is the ball going to be? Kukle, do you want to come tell us what you think? Okay, Kukle, what do you think the ball costs?
I think the ball costs 5 cents, sir.
I do too. How did you get that?
Because if you say if the ball costs 5 cents and you add and the bat costs 1 rand 5 cents, then that will give you 1 rand 10 cents.
It's so true, man. And this is just one of these brain bending things. It's like your brain just really wants 10 cents and $1.10. And yet when you think about it logically, the ball has to cost 5 cents. And this is a very famous question. So this has caught people all over the world. And it's when your brain engages predictive thinking instead of like really going through it. Just give me a thumbs up if you understand why it must be 5 cents. Just want to check, and then we're going to move on. Okay. That was a sneaky one, but I hope it brought you some joy. You can try it out on your brothers and sisters or friends at school and cause them to think hard. Okay, let's go back to what we were doing. So here is a more typical exam question. And I want you to work out the answers for me to A, B, C, D, E. So I'm giving you a table. Bring back the fruits quiz. And of course, I'll see what I can do. There we go. So if you are stuck, you can ask a question, but I think for most of you, you can just get going with this question. And you can pop your answers in the chat as they appear to you. Okay. So my first two answers I've put on the board, and if there are any questions, please let me know. Okay, what about C? C is going to be female and play sport. Now I'm just using F and S because it's both of these. So this would be female and play sport. That's going to be 21 out of 80. And then D, that's going to be equal to, that's just the calculation from earlier. Okay, let me slow down for a little bit, give some time. So probability of females 50. It's quite helpful to put this into decimals. So what are we getting for 50 over 80? So I'm getting 0.375 for this one. And if I wanted to convert that, I'm going to put that into decimals. So what does that mean? So I've done the various calculations, and after doing those calculations, I want to ask you, do you think that sports preference are independent of gender? So what we're asking is, here's gender over here. Here is play sport and don't play sport. And we're trying to say, are they independent? So does it tell you anything? If someone's male, does that tell you anything about whether they play sport or not? And so based on this calculation, I want to know, are they independent or are they not independent? And what's the reason? So I'm still waiting for some people to commit. Even if you get it wrong, it's important that you commit. So far, Ntokozo was the only person who's committing. Now, when we check for independence, we basically are checking for this rule, except the A and B are they're just like placeholders, right? So is the probability of, now in this case, it's just going to be probability of F, and this is going to be the probability of S, and this is going to be F and S. Is that statement true? If it is true, then they're independent. If it's not true, they're not independent. No worry, Khamutsang. You can see the recording to see how it finishes. Who wants to be brave? I know I'm pushing you for this first lesson. Are these independent? Okay, they're not independent. They're not independent because this is not equal to this. Yeah. So that's all you have to get used to doing. Now, the reason students find this confusing is they get mixed up, like, should I do female? Should I do male? Should I do sport? Don't play sport. You just choose one. So you choose one from the first event, so male or female. You choose one from play sport or don't play sport. And then you need to choose the and of those two that you chose. Now, obviously, if you chose male, it'll be a different group than if you chose female, but the choice is yours. Both ways will get you the correct answer. Okay, let's squeeze in one more question. If there's time, let's see if I can find one. Let's just okay, let's just choose this last one. We'll just do this one, and then in the next lesson, we'll do ones where things are missing. Okay, so here is an all exam question. A tournament organizer conducts a survey amongst 150 people at a local sports club to determine whether they play tennis or not. The results are shown in the table below. So first you answer these two questions, A and B, and then you can say, try and answer this question. Over to you guys and girls. Awesome. Thank you, Kultham. For your kind words. So a couple of answers coming in for females. So the tricky bit here is there's no totals yet. So I think I'm going to add some totals columns here. We'll make this 80, and that's 70, I think. And this would be 80, and that would be 70. And I guess, oh, that makes sense. That would be 150. Yeah. So that's quite helpful. So probability of being a randomly selected person, probability of being female from this group is 70 out of 150 because there's 70 females in this group. What is the probability that a member selected at random is a female and plays tennis? That's a much smaller group. So plays tennis and female, that's going to be that. So the probability would be 20 over 150. Now, the problem is we don't have all our information yet. You need to work out some extra stuff. Who would like to come online and show me the answer to finish off the lesson here? What's the last bit of information I need to work out? I'm a little bit, there's one piece of information I still need. Who thinks they know what information is missing that I need to work out? Yeah, let's go to William. Can you unmute William? Level, that would be awesome.
Hello, sir.
Hey, William. What's the information do you think I still need?
So you have the information of the probability of a female and playing tennis, but we don't have the probability of a female times the probability of playing tennis.
Okay, so well, we do have the probability of being a female and playing tennis, which is this one, right? So we have that one. And we do also have the probability of being female. But there's something else which I need. It's almost like I've got the probability of being F, and I've also got the probability of being F and playing tennis, but I'm missing something over here. What do you think I'm missing over here?
You're missing the probability of playing tennis.
Exactly. So what's the random? So if you look at the table, what is the probability that a randomly chosen person plays tennis?
The probability is 70 over.
Yeah,
Wow.
I think you're right. Yeah,
I think it's
because if you look at the column here, playing tennis, this total is 70. So a randomly chosen person, the chance of a randomly chosen person playing tennis is 70 out of 150. And the probability of a randomly chosen person being female is also 70 out of 150. And what we need to figure out now is what that is. And then we also need to work out, we have the answer for this already, F and T, which was 20 out of 150. So are they independent or not? Let's go to our calculators. I get 0.21777777778 here. So that is for the one side. And then for this bit, 20 out of 150, it's 0.13333 and so on. So you can clearly see that they are not independent because this is not equal to this. You can round, look, Kwesi, we normally look to see, I did the extra decimal places just to make sure that to see if they were the same or if they were different. I suppose you could have rounded off in this case, yeah. But you just have to be careful that you don't miss something if they're close. All right. The answer is they're not independent. And so I think that you guys have done really well today. And so I think it's time for us to wrap it up. Lebo, if you could put the poll in the chat, and then I'm just going to answer any questions that remain. From Amukalani, I see you had a question. Let's unmute. Amukalani, what's your question?
So my question was, what if will there ever be a possibility where it's asking for the event of tennis and maybe for example these learners are not playing football, for example, it will ask us for the possibility. Then, like, wow, what do
Yeah.
we do?
Okay, so they're always comparing the two events. The one event is going to be on the rows, and the other event is going to be on the columns, right? And you always choose one from each of the events, right? So I could have chosen here, I could have chosen the probability of being male, then the probability of not playing tennis, right? So I'll call that T dash. And then I would also need to work out what is the probability of that. Now that would be a harder way to do it, but it would still be a valid way of doing it. Okay, because I'm just choosing one from each of the categories, and then I'm choosing the intersection to compare them. But I don't want to spend too much time on that because I think it's going to confuse people. I want to keep it nice and simple for now. All right, we will continue.